Okay, I'm going to kind of review the topic of FOIL real quick because it's going to help us talk about how to factor a trinomial, which again is sort of tied to the distributive property and FOIL and all that stuff. We're just trying to do that backwards now. There is a reason why we do this stuff. I won't go into that just yet. So for now, wax on, wax off, and let's go ahead and give these a shot. So again, you should be pretty familiar with these by now if you're in a chapter on factoring. We're going to start by multiplying each of these polynomials. So if you remember, that means that the x needs to be multiplied by each of the terms in the other parentheses, and then the 2 does as well. So we'll start with the x. So we know that x times x gives me x squared. X times 4 gives me 4x. And then if I multiply this other part here, 2 times x will give me 2x. And I'm sorry, 2 times x will give me 2x, and then 2 times the 4 will give me the 8. And now notice here, just for a second, that the 2 and the 4 kind of add to give me this middle term of 6x. Okay, so that's just something to think about here. So the 2 plus the 4 give me the middle term of 6x, and then we bring down the 2 times the 4 gave me the 8, and then we'll bring down the x squared and the 8. Okay, so the x times the x gave me the x squared. So that we'll talk about more in a little bit. So again, we'll do this next one. So x times x, notice again, an x times an x is always giving me an x squared. X times negative 5 will give me a minus 5x. And then if we multiply here, negative 4 times x would be a minus 4x. And then finally, a negative times a negative will give me a positive. So notice that if you have 2 plus signs or 2 minus signs, this kind of end term without the x's will have a plus at the end. So when we had 2 pluses, we ended up with a plus 8 here. And we're actually going to end up with that here too. So this would be, if I combine these two, negative 5 and negative 4, well, just like before, they'll combine to give me a negative 9x. And then my plus 20, I'm going to bring that down. Again, notice that that sign here, when both of these signs were the same, that ending sign was a plus, okay, on the constant term. All right, we got one more to go, so I'm going to take, again, x times x, as always, is giving me an x squared. This will give me a minus 6x and a plus 5x. And then now notice that when the signs are different, when I have 1 plus and 1 minus, that's really the only way that I'm going to get a minus sign here at the end, is if I have one of each sign. So then finally, if I have a negative 6x and a 5x, I'm actually taking the difference of these. Unlike these two, I really just added them and kept the same sign that was negative. Here I added them and kept the same sign that was positive. So in this case, though, I have to take the difference because I have one of each sign. So this would be x squared minus x to combine these two. And then minus 30 I'll bring down. Again, these are all unlike terms, so that's as simplified as we can get. So just a few little hints or things to think about as we get into these next types of problems. Notice we've always got an x squared, some number times x, and a number. An x squared, some number times x, and a number. X squared, some number times x, and a number. All right, so keep that in mind for what we're about to do. Okay, now here's where it gets tricky. We're going backwards. I've given you the foiled out expression. What I want you to do is I want you to give me, what did this factor to? And when you're dealing with a trinomial of this form, x squared plus some number times x plus some other number, it's always going to factor into this kind of 2 parentheses sort of thing. So remember that in these previous problems, all the ones we had were these 2 parentheses, x, and then plus or minus some other number. So here we go. Let's start this off. So if you remember, we always started when we were foiling these out with 2 parentheses. Okay, so I'm going to try and see if I can get this to work. Let's also think about how we got that x squared. Okay, so we got that x squared by having an x term in the front here and here, because we know that if I were to FOIL that out, an x times an x gives me an x squared. Now the tricky part is, well, how do we get this and this thing here? So let's talk about this one first. Okay, to get an 8, we would have to, multiply two things. These two numbers would have to multiply to give me 8. So I'm going to have to think of any two numbers I can think of that multiply to give me 8. So in this case, all right, so we always have one of them. So 8 times 1 gives me 8. 2 times 4 gives me 8. And I think that's it. I think those are the only things, integers at least, that will multiply to give me 8. So 8 times 1, 2 times 4. Now what I need is, since both signs are the same here, I know that the middle term should add to give me 6. What I need is two terms, or the two factors that are going to add to give me 6. So 8 plus 1, so they multiply to give me 8, but 8 plus 1 gives me, oops, getting ahead of myself. 8 plus 1 equals 9, so that's not true. However, 2 times 4 gives me 8, and 2 plus 4 gives me 6. So that actually is the middle term, and you'll be able to see how this works here in a second. So let's fill in a plus 2 and a plus 4. So if we were to kind of FOIL this out now, you'll see this. X times x gives me x squared. So that I took care of. X times 4 gives me the 4x here. Then 2 times x gives me 2x, so you can already see that's where my 6x is coming from, and I need these two to multiply to give me 8. Otherwise, I'm never going to get that plus 8 at the end. And if you combine these like terms, you would see it would match that 6x right there. Okay, so I know that this is the factored form of the answer that I want. Okay, so this factored form of this would go to that. And that's actually one of the problems I did earlier. So I wanted you to kind of see that I'm not completely lying to you. If you were to FOIL this out, it would give you the same thing as that. From here on out, these are not examples we have done before, but let's do the same sort of thing here. So again, I'm going to start by two parentheses. See that x squared, some number times x plus a number. Since I need an x squared, I'm obviously going to need an x and an x here. Okay. And now again, always look at this number first. You need the factors of that constant term, or the number that doesn't have any x's on it, that will add to give you a negative 6. Now, since we have a negative 6 in the middle, I also know, since that's a plus at the end, I know that both signs have to be the same. So in this case, since that was a plus at the end, both signs have to be the same, either both plus or both minus. Here they were both plus. In this case, since I want them to add to give me a negative 6, I'm going to need both signs to be minus. A negative times a negative could give me a positive 9, but maybe add to give me that negative 6x in the middle. So think of some factors of 9, anything you can think of that multiplies to give you 9, but adds to give you negative 6. So again, I'll think about this here. I know they both have to be minus, so I could do negative 9 times 1. That's always a possibility. Negative 9 times negative 1 will multiply to give me 9, but that adds to give me negative 10, so that won't work. We got 3 times 3. Negative 3 times negative 3 is 9, and then negative 3 plus negative 3 is negative 6. Yeah, I think that's going to work. So let's fill in x minus 3, and then let's just check this out one more time to see if this works. So x times x is x squared. X times negative 3 will give me a minus 3x here. That will also give me a minus 3x. And then negative 3 times negative 3 is plus 9. So that's the only way I would get a plus, is if both signs are the same. And then if I combine those like terms, that would give me that. So if I combine these two like terms, that would give me that negative 6x in the middle, and I would have the same expression. So I know I've got the right answer here. Now, the only thing your teacher might tell you, and I'm a little bit of a stickler for this, because if you're taking a multiple choice state test or something on algebra, you probably won't see that answer for the multiple choice. You can actually go a little bit further with this example. Since both factors are identical, we can actually write this as, if we're taking something times itself, we can write this as x minus 3 in parentheses squared. Because remember that anything times itself is the same as squaring it. So, it's like having 3 times 3 is the same as 3 squared. X minus 3 times x minus 3 is the same as x minus 3 squared. Okay, so that's where we could get that from. All right, we got one more to go. And I'm really only going to stick with problems that don't have a number in front of the x squared. That's going to change the game today. You might say, well, you're kind of contradicting yourself. There is a number in front. There will be, but you'll see what happens here in a second. In any factoring problem, always, 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 the first thing I want to do is look for a greatest common factor. And if you look here carefully, we've got a 2, a 10, and a negative 48. They all have a factor of 2. So I can actually pull a 2 out of all of these things. So I'm actually going to start by doing that first. So I'm going to take a 2 out of all of these things. And when I do that, all I'm doing is just dividing each term here by 2. There's no x's or anything I can take out because that 48 doesn't have an x on it. So all I can take out here is a number, which is 2. So if I take this out, 2 divided by 2 is just going to leave me with the x squared. 10 divided by 2 would give me that 5x. And 48 divided by 2 would give me a negative 24. And now you might think, okay, well, in the previous video we were done when we did this. Well, think for a second. Look at the inside here. That will actually take another step to factor. So we pulled the 2 out, and now step 2 would be, so that was step 1 was to pull the 2 out. Step 2 will be to see if we can factor the inside anymore. So I know I pulled a 2 out, but I also know that these inside type problems are trinomials that we can probably factor into these two parentheses. So if we think, ignore the 2 for a second, we're just going to put that in our answer, and just look at this inside part right here. So just look at this stuff. Okay, we've got the only way to get an x squared is an x times an x. And the only way to get a negative 24, because we said before, if it's a plus here, both signs are going to be the same. If the last term is minus, we actually know that we need one of each sign. We need one plus and one minus. A negative times a positive is the only way to get a negative number. If we had 2 of the same signs, it would have to be positive. Okay, so now again, look at your last term here, which is that 24. And we need factors of that 24, anything we can think of, that when we add them will give me 5. Now, we've got to be careful because we're going to need one positive and one negative. So I'm going to start listing them out here. We always get 24 times 1, and I'm going to make one of these negative. 24 times negative 1. Unfortunately, though, those add to give me 23, so that won't work. Let's try 12 and 2. Maybe that'll work. So 12 times negative 2. Again, if I add those, I get 10, because one positive, one negative, I have to take the difference. That gives me 10. Let's try 3. So we already tried 1 and 2. Let's try dividing by 3. That would give me 8 times 3. So I'd get 8 times negative 3. And, oh, wait a second. This one might work. 8 minus 3. So they multiply to give me negative 24. But 8 plus a negative 3 will give me 5. And that's what I want for the middle. I do need to be careful about the order here. Since the 8 was positive and the 3 was negative, the 3 needs to go with the minus and the 8 needs to go with the plus. Otherwise, you're going to have a sign error and you're actually going to end up with a negative 5x in the middle. And that should pretty much be it. I'll leave this to you guys to first FOIL out that inside and then distribute the 2 in, and you should be all the way back here with your original problem. But that should be the factored form of that. Now, what we did not talk about in this video that we'll talk about in later videos, what if that 2 didn't factor out? You know, what if and I don't know if this is going to factor, but, you know, what if I had something like this? What if I had something with 3x squared plus 10x plus 8 where I can't take a number or an x out of all these things and I have to factor it with that number out front? There's more on that to come. Also, another thing to note is that if you have a polynomial, like let's say, I'll do this kind of up here, x squared plus, let's say, 2x plus 4, where you're listing out factors, your signs have to be, since it's plus and plus, it's got to be plus and plus. Your only factors of 4 are 4 times 1 and 2 times 2, and none of these things add up to give you the middle. It's possible that your polynomial can't be factored, in which case we write prime, meaning there's no nice even integer factors that will factor there to get that. There will be a way in Algebra 2 you'll be able to solve certain things like that, but for now we'll just write prime if we get a polynomial that will not factor.